Hello, I welcome you all to your own channel MSK Learnium. Now in this video we will start the new topic, that is vector differential operator. So vector, you know, in physics we already learned that scalar and vector quantities. So vector is one which is having magnitude as well as directions. So vector is very vast application we are using in engineering mathematics, also in physics, right, for fluid flow and for magnetic concept, right, magnetic field, etc. So here we will see that the vector differential operator. So the vector differential operator, we will denote it with a del, defined as delta is equal to what? That means you can say the vector differential operator I of dou by dou x plus j of dou by dou y plus k of dou by dou z, where I, j, k are the unit vectors, right? And dou by dou x means we are differentiating the position, partially differentiation we are doing. So this is the example of the vector differential operators. So now we will see the gradient of a scalar point function. So the let phi of x, y, z be a scalar point function of position defined in some region, a space. Then the vector function I of dou phi by dou x plus j of dou phi by dou y plus k of dou phi by dou z is known as the gradient of phi, and it is denoted by grad phi or del of phi. So grad phi or del of phi, del you know already, that I of dou by dou x plus j of dou by dou y plus k of dou by dou z, and phi is a function, right, a scalar point function into phi. So when you multiply with the del, that is vector differential operator, with the gradient, then it will become the gradient of a scalar point function. That means I of dou phi by dou x plus j of dou phi by dou y plus k of dou phi by dou z is known as the gradient of a scalar point function. Then there are the properties of a scalar point function. You should know that if f and g are two scalar function, then gradient f of plus minus g, we can write gradient of f plus minus gradient of g. Similarly, if the two scalar function, let's say f and g, then their product, the gradient product, we can say f of gradient of g plus g of gradient of f, right? So these are very important properties which will be applicable while solving the problems, right? So similarly, third properties, we can say the two scalar function, let us f and g, then the gradient of f by g, you can write g of gradient of f minus f of gradient of g by g square, where g should not equal to 0. So these are the things, that what is the vector differential operator and the gradient of a scalar function and their properties. Let's move to the next. Then here you have one more concept you need to learn, that we call it as a directional derivatives, right? So directional derivative is what? Let phi of x, y, z be a scalar function defined throughout some region of a space. Let this function have a value of phi at a point P. Then the directional derivative of phi at P, we can say d phi by di or dr, means that simply ordinary differential, it is like that, d phi by dr is a directional derivative. So there are the two theorems you should know. The theorem 1 is what? The directional derivative of a scalar point function phi at a point x, y, z in the direction of unit vector E is equal to E of gradient of phi is equal to E dot del of phi. So this is one of the theorem. Second theorem is what? That delta of phi at means the del of phi at any point is a vector normal to the level surface xyz is equal to constant throughout the point, where c is a constant. So this is what you have a just introduction about the vector differential operator. In upcoming videos we will see some important problems and some important concept. Thank you.